Hello internet viewers, and today we will be doing another update of this wheeled robotic platform which I've been making lately. So you can see it right here. I think in the last video I was talking about how I was going to put the wheels on, and now you can see that the wheels are in fact on the robot, and I managed to get them so they are not only mounted but they do turn with the motors as well. And of course I have 4 of these 6-inch wheels on each of these 4 cordless drill motors. So this robot has 4 cordless drill motors, so that means that I'm going to have 4 motor drivers to drive all 4 of these motors when I get them. And of course those motor drivers, I will probably connect them to an Arduino or something, and then I can program this as a robot to move around and eventually get some sensors as well. You can see that on the ends of these motor connectors I put these Anderson power pole type connectors, and just to demonstrate how they connect, this is 2 different motors and they can connect to each other like that. Obviously you wouldn't do this, but you would connect them to a battery or to the motor driver. And what's special about these connectors is that these connectors can connect in very interesting ways. For example, you could pair them up together like this, and it doesn't matter which end is male or female, because the connectors will connect to each other regardless. And you could see that I put some wire here. This is 20 gauge wire. In my opinion, it's a little thin, but it should be fine for what this is going through. I believe these motors are about 1 amp, and that is 1 amp at 5 volts and about 1 amp or 1.5 amps at 12 volts as well. And that's what I'm going to be running these motors on. Though these are 18 volt motors, I will mostly run them at maximum of 12 volts just because that's the kind of battery I'm going to be using. And these motors, even at such a low voltage at 12 volts, these motors will run really fast. These are really powerful motors which I have here for this kind of application, and that is not even considering the fact that I have 4 of them, so that's a lot of power just to drive this little aluminum frame. You could see on these 2 edges I put some risers in place. And what I'm actually going to do this is I'm going to have a second level of aluminum, and that's where I'm going to mount the panel to house electronics. For example, I think what I might do is I have this piece of aluminum bar, and I might put pieces across here and across here, obviously having these risers on the back end, and that'll make an uplifted square thing, and that will allow me to attach the electronics using one of these cutting boards. And these are HDP poly cutting boards, so what I can do is I could mount them in between these pieces of aluminum, and then I could mount motor drivers on the top of them or on the bottom of them, or batteries, using Velcro or screws or whatever I need to use. So I am going to be buying motor controllers. I saw some on eBay I like, but the thing with those motor controllers is that they're rated at 2 amps. So I have to make sure that these motors do not draw more than 2 amps. And let's find out using a multimeter and my power supply. You can see I have everything set up on this desk above the floor area where I'm working right now. So this is just the desk area above where I'm working. So you can see that this black box is the power supply which I use. It is a computer power supply, and then this is just a black box which has all of the posts to connect to. I don't have them labeled right now. I just remember off of memory that this is ground, this is 12 volts, this is 5 volts, and this is 3.3 volts. Right now it's on 3.3 volts, but 3.3 volts is actually not enough to really drive those motors. So we're going to try 5 volts and 12 volts. So let's turn it on and try to measure the amperage of the motors. So the motor which we are going to be running is this motor right here. And you can see this is the cable for it. And let's just get it working. Keep in mind that this is ground and this is 5 volts right now. But of course, the polarity of the motor doesn't really matter. It'll just spin in either direction. So you can see at 5 volts the motor does spin just fine. And now let's measure the amperage that it's actually pulling off of that. So here is my multimeter and I'm going to set it onto amps. This is an old Radio Shack multimeter when Radio Shack was still a thing. But most multimeters kind of work like this, where you measure voltage by putting the positive pin onto here, and you measure amperage by putting the positive pin onto here. It can measure a maximum of 10 amps, but you could also measure up to 400 milliamps on this rail. So that's kind of interesting. So let's wire this up so that positive goes in and then negative comes out, but that's still positive to the motor. Alright, so let's fire this up now. Be careful not to connect it with the metal. So it's about 1.1 amp. You could see what I was trying to do is I was trying to put resistance on it, and that would increase the amperage that it would draw, I think. So let's just set this down somewhere where we can still see it. And I'm going to try to put resistance on this wheel. So that does present a bit of a problem. You could see that if we put a lot of resistance on the motor and almost try to stop it, it can go up to drawing about 4 amps. And that's not very good. That would certainly damage the motor controllers, which I'm going to use. Let's try 12 volts now and see if that's any different. So same thing at 12 volts, we're just going to make it go. And you can see without any resistance, it stays at about 1.5 amps. Now let's try with resistance. So you could see if I put resistance on this wheel at 12 volts, it would go up to 3 amps. But I wasn't putting as much resistance as I could be at 5 volts. Just because the motor had a lot more power at 12 volts. And in addition to that, I was trying to stop it with my hand. I know it's not probably the best thing to do, but yeah, it would have heated up, I guess. So it does have more power at 12 volts, and that means that it doesn't get stuck as much and draw a bunch of amps. But I think this might be manageable. I Depending on how I wire the motor controllers, I might be able to wire them in parallel or something so I could get more amps out of a single motor. But the thing is that I'm just buying the really cheap motor controllers off of eBay just because that's what's cheap and that's what is available. I could get more powerful motor controllers, of course, but if I did that, then it would be much more expensive. So I think what I'm going to do is I'm just going to buy the cheap motor controllers and I'm just going to see how it goes. This robot shouldn't face as much resistance as I had shown. I can do things to help it not face that much resistance and burn up the motor controllers. Obviously, first thing I could do is I could put a fuse on the motor. That would be an easy thing to do. I'll probably get some automotive fuses, I guess. And I could put them in an automotive fuse block, and that would be for fuses going on each of the motors as well as fuses on the battery to the entire robot. Maybe a circuit breaker as well. Also, what we might be able to do is add some sort of feedback system to these motors. So you can see that on all of these 4 motors, there's a white disc separating the wheel from the actual shaft of the motor. Here's a vertical view of it right here. So what we have is the wheel. The wheel is bolted onto this white disc. You can see it's actually made out of one of these cutting boards. These cutting boards are great for sheet plastic material. And this cutting board piece is cut out in a circle and it is threaded onto the shaft of the drill motor. And of course there's another nut here which secures it tightly onto the shaft of the drill. And of course the wheel also pushes down onto the shaft of the drill, so this isn't moving anywhere. But this piece of plastic, the way it is designed is that it's just supposed to be a hub for the motor, as I have described. But I think we might be able to mount some kind of sensor on here and use this as some kind of feedback system to measure if the motor is moving. And of course, this is useful to measure how far we're going, how much the wheel is spinning, and in addition to that, it'll also measure how much friction is being placed onto the wheel. Because if this motor exerts a certain amount of force, say you turn it on, you want it to go somewhere, then a feedback system here will tell you exactly how many times the motor has turned and which angle you're at right now. So it'll basically turn into a servo motor. And what we can do with that is, in addition to having fine motor control, which is probably the main point you would do it, you would also be able to have a shut-off system which would detect if this motor has too much friction and then it would just stop. So that would be another good system to use rather than just having a fuse blow. In reality, I will probably actually do both. And in addition to that, I want to make my own motor controllers which are better than the ones which I'm going to buy. This is actually another solution which we could use. You can see these right here. These are relays which I have made. These are relays which are single pole dual throw. So you can see this is normally closed and this bolt is the normally open, and this is what flips in between them. I don't know the technical terminology, sorry, but I made these relays, and that might actually be another good idea, because these relays, though they consume about as much amperage as the motor does, 1 amp, these will not encounter friction or anything. So they will maintain a constant current draw. And we could of course wire these relays up in an H-bridge configuration, and these could control the motors. So in a way we could have an indirect control of the motors. Of course it is overcomplicated. You could just use a couple of MOSFETs. In fact, I think these drill motor triggers, they have MOSFETs in them, so you need about 4 of them to make an H-bridge. So obviously we would have to buy more, but that might be a start right there. But I have already built these, and I have all the materials to build more of these. You could see that it's just bolts, magnet wire, and another bolt. I actually made another video showing how to make one of these, but this is a better version which I made. This one is much more reliable than the other relays which I made before, and when operating it at 5 volts it will always switch on and off. And of course it's adjustable too, so if it breaks or anything, if it stops, I could adjust it as well. Of course, one thing is that this board of relays is pretty heavy. This has 4 relays on it, and it's an entire cutting board right here. I could get 2 more in here, but I don't think I would need to necessarily for these motors, because in a simplified setup I could drive a motor with just 2 of these. So 2 of these relays can create an H-bridge, and 2 of these can also create another H-bridge. Of course, that leaves us being able to drive 2 motors, of course, right? But no, that's not right, because what we can actually do is, since our motors are parallel to each other, we have 4 motors, and I could run this side off of one H-bridge and this side off of another H-bridge. So that might be a pretty good idea. I'll keep that in mind, and that will save us from any amperage problems. I think this project is gonna go pretty well, just because there are so many different options that I have, and so many different options I could implement concurrently to make this thing actually work. So we are done for this 3rd update. I will come back in the 4th update, and I think that will show how I'm going to actually install the motor controllers, and later we can get on to programming it and then actually getting it to do something mildly useful. Another thing to look up for, I guess, is I'm going to make videos on how I got these motors to mount to these wheels. I actually already have some video footage on how I did that, but I'm still working on it, I guess. And I might also make another video kind of unrelated to this as well, about those relays and how you can make them. And I also might make another video in addition to that about sensors that I can make for a robot, because of course we are going to need sensors. I was looking into gyroscopes and also magnetometers to measure magnetic field data, as well as just some basic stuff you could get off of eBay, such as ultrasonic sensors, infrared sensors, tilt sensors, what else? Touch sensors, which would just be a momentary switch. These are the kind of things we're going to have to put on here, just so it doesn't get stuck, or it could actually do something maybe. Also, I could use a solar panel as a light sensor, I think. But so just look out for that content. It is coming. And that is it for today. See you next time.